Hi guys, welcome to the second webcast of the week. Today we're going to be talking about joints. First I want to define them, or classify them in two different types of ways. There's three types you can classify them by structure. That's fibrous, synovial, and cartilaginous. And I want to point out that today we're going to be focusing on synovial. Today we're going to be focusing on the synovial joint. Do that in red as well. And there's also three ways to classify each joint by the type of movements they produce. So there's synarthrotic joints, which are joints that don't move. There's amphiarthrotic joints, which are joints that move just slightly, just a little bit of movement. And there's diarthrotic, which are freely moving joints. And then an overarching principle of joints is that as you increase stability, you're going to decrease the flexibility of the joint. And vice versa, if you decrease the stability of the joint, you're going to wind up with an increase in flexibility of that joint. So let's hop right into it. I'm just drawing this little barrier around here so we don't get anything confused. And I'm just going to go over the components of a joint and draw them on this diagram. Components. First one I want to talk about is articular cartilage. Articular cartilage. As you can see, I've already drawn the two bones that I have coming together into a joint. And remember, it's going to be, we're going to use a synovial joint or a traditional joint as our example here. Articular cartilage. And that is going to be found on, oh, that's too big. Covering the edges or the ends of the epiphyses of the bone. And what this is going to do, this is hyaline cartilage. It's going to both create a smooth surface for smooth joint movement, as well as absorb some shock so that you don't crush your bones from just day-to-day activity. So it's going to absorb compression and create a very smooth surface for the joint. The next area is going to be the joint cavity. And I want to write that in just in regular yellow here. Joint cavity, because this is just a potential space. It's going to be defined by the next component. Joint cavity. That's going to be the space between the two bones. So you can imagine, not quite in there. The joint cavity would follow something along this line, and this is the cavity that, like I said, it's just a potential space. That's how it's defined, where the joint is found, the synovial joint. And then this next component is what's really going to define where that joint cavity is, and that's the articular capsule. Articular or movement, articulate. Articular, you can equate that with joint. Articular capsule. And I'm just going to go ahead and follow this same line that I drew here, because this is where you're going to find it. The articular capsule. There's going to be two components. Two components of this articular capsule. There's going to be the inner membrane, the inner surface, which is the synovial membrane. Synovial membrane. And that's going to be composed of loose connective tissue and make synovial fluid, which is what's found inside the articular capsule. Synovial membrane. And the other layer of this articular capsule is going to be the fibrous capsule. And this fibrous capsule is actually going to be continuous with the periosteum. Continuous with the periosteum. And go along the outside of this articular capsule. And that's going to be made up of dense, irregular connective tissue. And this strengthens the joint. So this is the fibrous capsule. Fibrous capsule. Let's scroll down here a little bit. The next thing is the synovial fluid. Synovial fluid. synovial fluid. I'm not going to draw that in because that would take up too much of this area that we're working with. We'll say blood filtrate. So blood filtrate found inside the articular capsule. Articular capsule. And the synovial membrane is responsible for creating and secreting this. And like I said, it's mostly a blood filtrate, and it also has special glycoproteins that help create it, give it its slippery properties, so that it can help the joints move freely. The next part I'm going to diagram is going to be reinforcing ligaments. So it's going to come from really probably above even what I've drawn. Follow along the outside here. And this is going to help stabilize the joint even more. So these reinforcing ligaments, remember a ligament is something that connects bone to bone, whereas a tendon is something that connects muscle to bone. And this is going to reinforce the joint. As you can imagine, reinforcing ligaments. And there's also going to be nerves and vessels coming into this area. Obviously, if it's going to be a blood filtrate, it's going to have to be vascularized, and you do have nerve innervation that comes into these joint capsules. And then some joints are going to have things called articular discs, or a meniscus. And that would be found, I'll draw it in here even though it's not quite, I haven't drawn it quite to accommodate it, but I'll write it in here. Articular disc or meniscus. And what this does is it fills gaps of bones that don't quite mate together perfectly. And what that then does is distribute the load of the joint. So you're going to find those in your knees, and also in your sternoclavicular joint, and in your mandible joint, or where your jaw comes and meets in with your maxilla. Or, I'm sorry, your temporal bone. And like I said, that's just going to distribute the load and help mate together irregular surfaces. So I'm actually not going to draw that on there. Absorbs load, mates irregular surfaces, or irregular surfaces. There's two other things I want to talk about, and that's going to be bursa and tendon sheaths. Bursa and tendon sheaths. Running out of colors here, so I'll draw this one in green. So bursa. Bursa is Latin for purse. Latin for purse. And what this is a flattened sac with that's lined by a synovial membrane. And this is going to prevent tendon rubbing in small spaces. So you can imagine in your shoulder joint. In your shoulder joint, there's a lot of small spaces where your humerus comes in contact with your scapula. You have your acromial process hanging over there, and there's going to be tendons squeezing in and out of small spaces, and to avoid friction you have a bursa in there, and that bursa is just going to be a cushion between the tendon and the tight space it's going through. And similarly, a tendon sheath is going to do the same thing. I'll draw this on this reinforcing ligament I have here, or let's draw one more thing here. Tendon sheath is going to be essentially an elongated bursa that wraps around a tendon. Elongated bursa. How much room do I have here? Plenty. Okay. So very quickly, I'm going to go ahead and draw something like this. This is the humerus. And then we'll have our glenoid fossa, which is part of the scapula, come around here, and our acromial process hanging out up here, which is also part of the scapula. Now if you have a tendon coming through here, it's going to be attaching from here and squeezing through this space and coming down this way. You know, with the movement of your arm, that's going to create a very tight space. So you're going to want to have this wrapped in a tendon sheath. And this is going to wrap the same way as that deflated beach ball analogy that I talked about with the membranes, or the serous membranes. I can't really draw that from how I drew this. But it's going to wrap around, and if you look on page 211 of your book, it's going to wrap around these tendon sheaths, or these tendons, and create a tendon sheath, or an elongated bursa. And then in here is where you sort of find more of the bursa itself. And this is just going to be a pouch that's going to ease the friction right here. So we have a tendon sheath, and bursa. That's going to be all for today, and thanks for watching again.